Alright, today we're going to go over some problems from your poster project part 2 congruent triangle sorting activity. So again, these are answers to problems directly off that activity, so you want to make sure in addition to doing this Edpuzzle, you are copying the answers onto your packet. So that way you and your partner have that information and you can move forward with your project. So some of these problems are tricky, so we're going to look at them in this video. The first one we're going to look at is number 6. So for number 6 like this, we want to figure out if and why triangles ABC and DEC are congruent. So something that is helpful is to take two different colored highlighters or markers or pens and highlight each triangle in its own color. So I'm going to highlight triangle ABC in blue. This just makes it easier for us to see what we're looking at. So ABC I'm going to highlight blue, and then DEC I'm going to highlight in purple, or this pinkish purple color. Okay, now I'm going to read the information that I'm given and mark it on my picture. So segment AB is congruent to segment DE. So AB is congruent to DE. And if you look at our right triangles, AB is a hypotenuse and DE is also a hypotenuse. Then we know that CE, so I'm going to put two congruence markers on CE, is congruent to CB. So I'm going to put two congruence markers there. This right angle down here tells us that both the pink triangle and the blue triangle are right triangles because it is a part of each triangle. And now we want to look. We said we have a hypotenuse, a leg, and a right angle. So when we have that, the theorem here is hypotenuse leg. Remember, hypotenuse leg is a theorem that only applies to right triangles. For number 9, here we know that AC is congruent to CE, so we have a side. Then we know that BC is congruent to DE. Then we have another side. Excuse me. Then we have our triangle here. And let's look at side, oops, this is not what I wanted to do. Let's look at side AB and side CD. I've highlighted them both in yellow. If you look, both of these sides are marked with an arrow. Now remember, that arrow does not mean congruent. That arrow means parallel. So just because these two sides are parallel, that does not mean that they are congruent. So here we do not have enough information because side is not a triangle congruence theorem. So here we're going to say that these two triangles are not congruent because none of our triangle congruence theorems work here. Number 11. So here we want to look at triangle ABC and triangle DBC. So again, use your different color highlighters to outline the triangles that you're talking about. So triangle ABC I'm going to make yellow. And then triangle DBC I'll make green. Alright, and now we can see the two triangles in this figure that we are talking about. So the problem tells us that segment BE bisects angle ABD. So angle ABD is this angle right here. If BE bisects this angle, it cuts the angle into two congruent parts. So I'm going to mark that on my picture. So now if you look in the yellow triangle and the green triangle, we have two congruent angles. Oops. And now we need to see what else we have. So we have angle, and then let's look at BC. BC is highlighted both yellow and green because it is a side in both triangles. So since it is a part of both triangles, we know that it is congruent to itself. So now for our triangle congruence theorem, we have angle, angle, side. This is not angle, oops, let me redo this. This is not angle, side, angle. Because for the angle, side, angle theorem, remember the side, the congruent sides need to be in between the two congruent angles. So this is angle, angle, side. All right, to number 13. So here we only have two triangles that we're looking at, so you can use your highlighters if you want, but not really necessary here because we only have two options. So we want to look at triangle ABC and triangle DEC. So this says that segment BD and segment AE bisect each other. So remember, bisect means cut in half. So if they bisect each other, we know that BC would be congruent to CD because it is bisected by AE. And then the same thing works the other way. We would know that AC would be congruent to EC because this segment is bisected by segment BD. Alright, now we want to look at this right angle. If you look, this angle that I'm going to highlight in blue, well, I'm going to highlight two angles in blue. These two angles here are vertical angles because they're across from each other. That's their relationship. We know that vertical angles are congruent. So if angle ECD is a right angle, then angle BCA is also a right angle because vertical angles are congruent. And now we want to look at our picture and we just want to read it in order. So when we look, we have side, angle, side. So that is your answer here. Side, angle, side. This is a right triangle. So when you see a right triangle, our first reaction is usually to say, oh, it must be the hypotenuse leg theorem. But you have to be careful. The hypotenuse is the side across from the right angle. So in this figure, BA would be in a hypotenuse and ED would be a hypotenuse. We do not know anything about the lengths of BA and ED. So you cannot say that the theorem here is hypotenuse leg. So just because you have a right triangle, that does not mean you automatically use the hypotenuse leg theorem. Alright, number 18 is the last one that we are going to look at. So in number 18, this one is tricky because you have to remember what you know about angle relationships when you have parallel lines cut by a transversal. So here it says AC is parallel to BD, so I'm going to highlight those two parallel lines in yellow. And actually, let's mark them as parallel. Remember, you mark lines as parallel by adding an arrow onto them. So now we know our picture says that AC is not congruent to, parallel to BD. And then it also says that AB is parallel to CD. So let's add two arrows over here to show that these two are parallel. Okay, so now, first we're just going to look at AC and BD. So they are parallel lines and they are cut by this purple transversal. So BC is the transversal. Remember, a transversal is a line that intersects two or more lines. So when you have parallel lines cut by a transversal, we have angle relationships. Let's look at angle ABC. Angle ABC and angle BCD, which is this one right here, are alternate interior angles because they are on opposite sides of the transversal and they are inside the yellow lines. So when we have alternate interior angles, we know that they are congruent. When you have parallel lines cut by a transversal, alternate interior angles are congruent. We have another set of alternate interior angles right here when we look at angle CBD and angle ACB. Again, these angles are on opposite sides of the transversal, which makes them alternate, and inside the yellow lines, which makes them interior. So now we have two congruent angles, and the transversal is a part of both triangles here. So it is congruent to itself. So when we look at that, we want to read what we have in order. We have angle, side, angle. So the theorem that we're going to use here is ASB.